So this trip I'm at Caledonia State Park, Pennsylvania, close to Gettysburg. Just a chance to walk through Appalachian Trail. Again, only did a little bit of AI because, again, the weather's good, even though it's November, and rather be outside in the park. But this video, maybe one or two videos, I'm looking to put together a actual agent or client for my Scamp. And this is where I'll bring in my MCP services and tools, combine them with using an LLM, probably be Granite for Jetson Nano. And then I'm going to be using Langchain. And funny thing is, about a week ago, version 1 of Langchain came out. It's been about 3 or 4 years since it was first released, but this is the first 1.0 release. I've rebuilt Langchain to be get rid of all the things that were confusing and duplicated and weren't really needed. And so I'll be using the latest version of Langchain 1.0.
So let's have a look at how I set up this first project. Again, it's running on my remote PIAI machine. So once I'd remoted into it, I could use UV, the UV package manager, to initialize the environment. Then I needed to use UV to set up a virtual environment. So once that's created, I activated with the source to the virtual environment. And next I just added the various Langchain packages. So added Langchain first. So I got Langchain version 1. I also installed Langchain Ollama, so I could use Ollama based models. And I installed the Langchain MCP adapter module so I can use tools, or MCP tools. So as I said, I'm using Langchain version 1. That just came out maybe a month ago now. And there's a summary in the release notes about what's in Langchain version 1, but it's been completely re-architected and actually runs on top of LangGraph, sort of getting to the lower level functionality as well. And the thing I'm interested in is this new create agent. I'm glad it came out, otherwise I'd be struggling with LangGraph to get agents going. But now agents is a part of LangGraph, and there's a nice high level abstraction of creating an agent with it, which makes life a lot easier if you're making agents. And the whole idea is you provide an input to an agent, which will use a model, and that model has ability to call tools and can call them recursively until it gets to whatever the stop condition is based on what the input is and what you've set up as the stop condition, and will provide an output, which is kind of what you want an agent to do, but having this agent module built into Langchain makes doing the whole thing a lot easier. So let's dive into the first piece of code I used for using Langchain. So I brought in the various, created the objects, or the classes, brought in the various classes I need from Langchain, which included chat Ollama, so this is the interface to an Ollama model. The create agent class, and that's the thing that gave us the ability to run an agent very easily inside Langchain. The MCP adapters to connect to my MCP tools. I also added in Langsmith imported traceable, so I could also watch how my code runs under Langsmith. Probably more on that later, but we'll have a quick look at what that produces. Also needed to bring in async IO time and the load dev environment to make use of traceable as well. So I load the dev environment, and I have a .env file here. So that has the basic details to set up Langsmith, and I grayed out the API key, but that's the API key you get from Langsmith to do this sort of stuff. I set the traceable decorator around my main function. Set up a start time. So the first thing, like we saw in the little diagram, we want to set up a chat provider. I'm using Ollama, so I'm using the chat Ollama provider that I just showed you. And this is where I set up what model I'm using inside Ollama. So I'm going to be using the Granite 4 because I'm going to be running this on the Jetson Nano. Set up my URL to that Ollama instance. Set up some parameters. So I set the maximum CTX, so the maximum context window size that will fit on my Jetson Nano along with the model. I set a max tokens. I don't know whether I really need this, but it's meant to help with resolving when it finishes with doing its work. Once it's done that many tokens, it's going to give up and just keeps it out of doing a loop. And I put the temperature really low, so the higher the temperature, if you're close to 1, then it's going to be more creative, but you're going to get more hallucinations, could get more weird answers. So I wanted to keep the temperature low, so 0.1 very low, so should keep mainly to the facts. So that's set up my actual LLM to be using in my agent, and then I set up the tools that I'm going to be using in my agent. So I'm using this multi-server MCP client to find where the tools are. So again, pointing at those tools I've created in earlier videos. So sets up a connection to the MCP Scamp tooling, which are MCP tools. Then I load in the tools here, and this is why I had to use a sync, because it has to wait on the get tools. And finally I define my agent. So this is the agent, and I say what the model is. So that's my model I just defined up here. The tools, which I just defined here using the tools class. I set up a system prompt, so I put in the system prompt just to ensure it's going to go out and use tools where available. Here's an example of doing a query or a prompt against that agent. So I set up my agent, I say my role's user, and the query I'm going to do is what state parks are within 100 miles of Lewisburg, PA. 100 miles, you get a lot of state parks, so I'll be able to see how much context window I'm using up with something like that, a large tool retrieve. Then for showing the results, we'll see in a sec when this runs, but I just show Scamp response, which is a dictionary item with a lot of details about what actually happened in the run, as well as the actual response. And then I calculate how long it took to run, show how long it took to run. And then I've got this one more print statement for just getting the final message that would be presented to a user if I was using a more generic chat interface to it. And then I run the whole thing. So that's my first Lang chart run. And to run this, I'm going to have to activate my virtual environment, and then I'll do a run of Playground Pi. This is a fairly complicated run, so we'll let it run for a while. So it's complicated because it's calling two tools. It needs to find the location of Lewisburg, and it also needs to then go out and get all the state parks within 100 miles. And there's a lot of state parks within 100 miles, so it's going to take a while to fill up the context window and then present the result with whatever the tool retrieved. So that took quite a while to run. So there's the results showing all the state parks. It took 156 seconds, so almost 3 minutes. And like I said, if we look here, this is the Scamp response. So that's the response straight out of the agent, and it has a whole lot of details in here. So let's have a look at this first. So an easy way to pass this. I don't know whether it's going to be very fast either, but let me grab that whole thing. And I'm going to go over to... So in continue, I'm connected up to Quinn3 Coder. So let me just say So it told me what it did. So it went out and got the location of Lewisburg, and then went out and looked up all the parks. And I can ask it queries about that. So the other thing that I had going on with this was I had Langsmith running, so the instrumentation for using Langchain running as well. So so I've set up Langsmith, and there's the run that I just did. So it's telling me how long it took, time to the first token, number of tokens it used, so 10,000 tokens for that, mainly because it had so much data retrieved about the state parks. And we can click on that, and Langsmith tells you things like this. So it shows you each of the actions in here, tells you things like what was building up the token. So this little symbol here says total of 10,000 for the whole run, and then if we look at the various parts, 2,110, which was probably just getting all the tool definitions. So tools use up quite a bit of context window. Doing the call to get location didn't really add much to the context window. Getting state parks, we see down here it's now up to 6,000, so quite a bit added to the context window. And then our total was close to 10,000, so I must have been building up more context, just processing the output. But Langsmith is kind of useful for breaking down to see what's happening, especially for Granite 4B, where it doesn't provide a lot of detail about what it's doing behind the scenes. I find I get a lot more detail back on something like OSS 20B or GPT OSS 20B. Okay, I'm feeling a little more confident about how Langchain works, especially Langchain 1.0. So what I want to do is change what I've just created into a web service, so that I can put an Angular front end around it. So basically be able to send a prompt to Langchain, have it process it, and send the results back to the user in one HTTP transaction. To do that, so I'm going to use FastAPI. So I've used that before, and that's an interface to web services, and then UVcorn is the actual web server that's used to host this application. Just typical thing with FastAPI, so declare an app object. So from my last piece of coding, I've moved creating the LLM and creating the multi-server MCP client out into the main logic as it starts up. So not many changes there. What I have changed is what I call the main function before, is I've now created it as a separate function. So I'm calling that lcChat for Langchain chat, accepts a string and returns whatever the user content in the response is to calls to this function. So that's the thing that's was my Langchain logic in the previous example. So now it's just a separate function that I can keep calling. And then the FastAPI part is use the apt-get decorator for a path to chat. So I pass it chat with a query string of prompt equals whatever my prompt is. And for this example, it's going to be a prompt to say, how do I make scones? So that should call the MCP tooling that I have in place. And basically what that will do will call the lcChat code here, do all the Langchain LLM stuff, get the response, and return that response to the user calling it. Then the final part of this code is just to get the web server up and running. So at the moment I've just got a main section here to run it. So the way we run this is, again, I'm set up and I'm running in my virtual environment. So I'll do a Python chat service, which is this new code that I put in place. Run that. We see it's running on port 8123, which is where I told it to run. I have an example of a query here, so that's what I'm going to use to test this. So let's go over to a browser. So to test out the web service, I already have a Chrome session going here. This is the URL that should pass my prompt as a query parameter. Let's try running that. And that's good. I got the result I'd expect, including the call out to WikiHow to get the link that would drop me into WikiHow for how to make scones. So the last part of this video, I wanted to make a simple web front end just to try out that web service. So as usual, I did it in Angular. I actually tried doing a vibe code of this to get a AI to create the Angular application. That didn't work very well. It seemed to not know much about standalone components and things, so it didn't end up working well. So I ended up just making a simple Angular application and wrote my own component. So the pieces in here, I created a service, an Angular service, just to do the call to the web service we just saw we created. So that's it there, and it passes along a prompt parameter to it, and then the other part was this chat component. So it's really just a simple form with a field for entering my prompt text and showing the resulting information on the screen. And finally, just have a look at the TypeScript code. So most interesting thing here is to call the web service that we just saw with the prompt. And the other thing I used was the marked component, so that converts markdown string into a HTML to be displayed on the screen. So basically that's what I'm doing here, is getting the result back from the Angular service that called the Langchain service, and then the result always comes back as markdown. So I just convert that into the response that is shown on the screen. So let's have a look at how this works. And I actually have already built this Angular application and added it as a static website to my my Langchain web services. So if I just call this once the service is running with its basic address here. So let's open that in a browser. So there we see the Angular application. Again, very simple, not a lot of decoration there. And I can ask it questions like what state parks are within 10 miles of me. Let's try that. Press the go. So that's going out, doing a web service call to that Langchain service. Langchain's running the agent and doing all the usual things that we just saw of calling tools to find out the information, and there's the result, and it's nicely formatted because it's come back as markdown. Then markdowns, the markdown components converted that into fairly nice looking HTML. And we can do other ones like how do you make scones? If I could spell it right. So they see it's, my AI should see that that's a how do you type question to put the link in this time. So let's try running that again. Okay, this time it got it right, that it put in the link to the WikiHow, and that's pointing to my local instance of WikiHow. So again, the idea of being in an RV is I don't want to have to go up to the internet. I don't always have connection, so it's going to, if I click on that, go over here, it takes me to my local WikiHow in the in the search mode, and I can click on that and get detailed instructions on how to do that. So they'll be useful in the RV if I have how-to questions like how to fix the car or how to fix the RV. And then again, it just shows you the AI response to the question as well, which may or may not be correct. But that's good. Just to let you know, so for my Scamp project, this is probably the end of it. I probably am not going to use this this web front end that I created. I think the Open Web UI interface that I've been using works pretty well as a web interface. It's easier to change things like what model it's pointing to and things more than using Langchain would allow me to do easily. So I think I'll be using Open Web UI most of the time, but there are some unique circumstances. So if I want to create, say, a device to use in my RV where I can talk to it like a home assistant, and maybe carry it around, and I'll just show you an example of that, then I may swap back to using the Langchain web service to respond to such a device, because those are the only sort of response that I wanted. But otherwise, for a web front end, I'd probably have to make something a lot more sophisticated, a lot more async, to get responses for, especially for thinking type models as they come back, and I don't really want to go down that when Open Web UI does a good job already. So that wraps up my Scamp AI project, unless I do something like that handheld audio assistant or add some more data sources in. This will probably be the end of it.